Hey guys, this is OKC Chedoze from SME. Today we're going to be solving this question from 2021 Senior Maths Olympiad. We're told to find the remainder if the sum of the coefficients of 2x squared plus 3x minus 2 raised to 2021 is divided by 28. So we'll start by defining a polynomial p of x that is equal to the polynomial we are given, 2x squared plus 3x minus 2 raised to 2021. One common property of polynomials is that p of 1 is the sum of coefficients of a polynomial. So to find the sum of coefficients of this polynomial that we're given in the question, all we have to do is to substitute x with 1 and to find p of 1, which is going to be 2 into 1 squared plus 3 times 1 minus 2 raised to 2021. And this goes on to be simplified to 2 plus 3 minus 2 raised to 2021. Which is 3 raised to 2021. And then, since we're told to find the remainder when this value here is divided by 28, it means that we're looking for what 3 raised to 2021 is congruent to mod 28. And so to proceed from here, we're going to make use of Euler's theorem. But before we go to Euler's theorem, we're going to first talk about the Euler tangent function. So the Euler tangent function is a function from natural numbers to natural numbers. It's written as phi of n, and phi of n is defined to be the number of natural numbers less than n, such that the GCD of n and the number will be 1. So it's basically the number of integers k, such that k is greater than 0 and less than n. K and n is 1, and the GCD of k and n is 1, right? Good. So that's what Euler tangent function is defined to be. And so, for example, if we're looking for phi of 8, we just have to count how many numbers there are less than 8, such that GCD of 8 and the number will be 1. So to do that, maybe we'll just list all the numbers from 1 to 8. And then we'll cancel the numbers that share a common factor with 8, which are 8, 6, 4, and 2. And then we're left with 1, 3, 5, and 7. And since there are 4 numbers that are relatively prime to 8 less than 8, it means that phi of 8 is going to be equal to 4. And so that's how the Euler tangent function is defined. It's just the number of integers, the number of natural numbers less than a number that are relatively prime to it. And then from here, we're going to talk about Euler's theorem. And so we'll just go down a bit now. So Euler's theorem says that for any a and n that are relatively prime, that is for any a and n such that GCD of a and n is 1, we have this to be true. A raised to the power phi of n is congruent to 1 modulo n. So this is Euler's theorem. So if we have any a and n, we have a raised to the power phi of n is congruent to 1 mod n, as far as the GCD of a and n is 1. That is, a and n don't share any common prime factor. And in our question, we are looking for 3 raised to the power 2021 mod 28. And since 3 and 28 are relatively prime, it means that 3 raised to the power 5 of 28 is congruent to 1 mod 28. Although we can start listing out the numbers from 1 to 28 to find what phi of 28 is, that's not a very feasible method of finding the value of phi. For example, if we're told to find phi of 2021, it will be very cumbersome to start listing numbers and cancelling out. So I'll show you an easier way of finding the phi of a number, which is the Euler tangent function of a number. So let's say we have a number n to be p1 raised to the power a1, p2 raised to the power a2, pn raised to the power alpha an. So basically, this is just the prime factorization of n, where p1, p2 up to pn are all distinct. Phi of n is going to be 1 minus 1 over p1 times 1 minus 1 over p2 times 1 minus 1 over pn times n. And then in our case, we're looking for phi of 28, and 28 is equal to 2 raised to the power 2 times 7 raised to the power 1. So phi of 28, right, is going to be 1 minus 1 over 2 times 1 minus 1 over 7, since 2 and 7 are the prime factors of 28, times 28. And we can simplify this to 1 over 2 times 6 over 7 times 28. And then we have 14 here, cancels here, we have 2, which is equal to 12. So phi of 28 is equal to 12, which means that 3 raised to the power 12 is congruent to 1 mod 28. So we'll just scroll down a bit here and continue with what we're doing. And then we can rewrite 3 raised to the power 2021 to be 3 raised to the power 2016 times 3 raised to the power 5, which is also the same as 3 raised to the power 12 raised to the power 168 times 3 raised to the power 5 mod 28. So these in fact are equalities. They don't even have to be congruences, since the value of since all the numbers here are equal. And then this is congruent to, from here we have that 3 raised to the power 12 is congruent to 1 mod 28. So we can replace 3 raised to the power 12 here with 1. So that's going to be 1 raised to the power 168 times 3 raised to the power 5 mod 28. And so 1 raised to the power 168 remains 1, and 3 raised to the power 5 is 243 mod 28. And from this point we can rewrite 243 as 224 plus 19 mod 28. And this is congruent to 224 is a multiple of 28. In fact, 224 is 28 times 8 plus 19 mod 28. So this is congruent to 19 mod 28. So this is, and so 19 is going to be the remainder if we divide the sum of the coefficients of 2x squared plus 3x minus 2 raised to the power 2021 by 28. And option C is the correct answer.